Hey everyone, how are we doing? So, working on chapter 13 homework in office hours now. Hey Noel, good to see you here. Working on chapter 13 in homework, office hours now. I don't even know what I'm saying. I was gonna do some chapter 13. Brayden, what's up? What do you guys and gals want to do? I'm drinking a Red Bull. I shouldn't be drinking a Red Bull, but you know me. I'm drinking those Red Bulls. Getting those wings. That's what we do right here. But doing well. Little chill music while we get started. Yeah, chapter 14 quiz. Why not? We've got a lot of videos on the other things. So if you hop in, we can do whatever you want. If you're here, you decide what we do. So if you're ever stuck on something, you swing by, we do it. Which quiz question are you working on chapter 14 quiz? And good job, because that assignment is coming up here soon. So which quiz assignment on chapter 14 quiz? What's the question start out with? Let me know. Brayden, so good to see you. Let's start out some U-Bot points. Oh man. In 1998, the Nabisco company advertised the 1,000 chip challenge. So as we say here every time, it all starts out by knowing your what. We need to know. Hey, Monster got back to me and said we have to... Did they... Oh, thank you, Brayden. It's very kind of you. Tell them they're missing out on the biggest opportunity of their life. I'd have to check with Haslam for signing anything, but just saying. That's why we're drinking Red Bull. That's it. Where's my Monster cans? I don't care about this Monster anymore. That's what I think about Monster. Monster's out. Red Bull's in. No more Monster. Take that. Send that to them. Clip it. We're switching back to Red Bull. Monster, you don't want this energy? Red Bull energy from now on. This is watermelon. They got guava. Who wants guava? I don't even like guava. I like watermelon. You want guava or watermelon? Everyone's like, I want watermelon. What the heck is guava? Probably guava's pretty good. Okay. Here we go. This one's a little tougher. We all know it boils down to notation. Let's put this in the video right here. 453, stat 201, chapter 14. Oh my gosh. My computer's making a bunch of noises. In 1998, as an advertising campaign, the Nabisco company. Not Nabisco, the Nabisco. Okay. The 1,000 chip challenge, where they say that on average that their bags have 1,000 chips. So does anyone know what these are in notation? Take a guess. I'll give you points no matter what you guess. But what do you think these are in notation? What are those in notation? As famously said, what are those? What are those in notation? Do you know what the notation is for these? We're going to just review notation. Kinda. It's not N. N can be derived from this. So they went to a bag of cookies, and in these cookies, they looked and they counted all the chocolate chips. These are like toffee chips or something. In the first bag, out of all the cookies that existed, there was 1,191. That makes this an observation of Y. So this kind of goes back to the dots with regression. We're not doing regression right now, but the observed value is Y. So that's what we're recording, the observed value of how many chips there are. Do you know what N is for this? What is N? Which is how many observations they have for how many chips, chocolate chips were in a bag. What is N? Don't worry if you get it wrong. We'll throw you points once again. So each of these is a Y. What is N? N is the sample size. So what is N? What is N? N is sample size. Well, so what is it? N is sample size. So what is it in this problem? What is the numeric value of the sample size? What is the numeric value of the sample size? How many bags of chips did they go to count how many chips are in each bag? How many bags of chips did they go to find how many chips were in each bag? Don't worry if you get it wrong. Well, so that's Y bar. Y bar is the sample mean, or the sum of all the observations of Y divided by the sample size. So how many bags did they go to? 14. Noel, you got it. There's 14 bags right here. So there's 14 bags total. And if you sum up all these values and divide by 14, you get y bar. Does that make sense what y bar is? Excellent. So let's hit the 5,000 point right there. So that's going to get you y bar, which is the sample mean, which is on average for all the bags. So what we actually need to do to make this problem easier is we're going to go over to jump right here. So jump's going to make this problem a joke. We're going to go to File, New Data Table. That's File, New Data Table, or Control N, quick key to get there. We're going to go back to the problem itself, and we're going to click here by going to Copy to Clipboard. Make sure to click Copy to Clipboard, and then hit Command C or Control C on a PC. I have a PC. And then go back after copying it and hit Control V. Now, very importantly, if you hit paste with column names, you did it wrong. You should see that it's blue. Notice it's blue, and we shouldn't see anything in the column name. So this was just a regular paste this time because there was no column name. It didn't say like chocolate chips. Now you can go right here and double click it and call it chips. This is not required, but it can be done by double clicking the name of the column and then calling it whatever you want to call it. That just gives it a name other than column 1. Not required. But it should look something like this with 14 observations, which is the first bag had 1,191 chips in it. Now, we'll use this in a moment, but we have the data in jump. In a moment, we'll use it. When we check the conditions, what is the first condition for making a confidence interval for the mean? The first condition for making a confidence interval for the mean is what? You know it, you love it. What is it? What's the first condition? Random. We randomly take bags of chocolate chips and we count. Lainey, good to see you there. So we randomly take these bags. Mubot loves that randomness. So we randomly take the bags. What's condition number 2? Condition number 2 is what? What is condition number 2 at all times for the remainder till we get to the test? 10%. Do you think we've taken less than 10% of all chocolate chip bags that exist in the world, of all Nabisco chocolate chip bags? Do you think we've taken less than 10% with our 14 bags of chocolate chips? Do you think we've taken less than 10% of all the bags that exist out there? Do you think we've taken less than 10% of all the bags that exist? And there's the conditions for the one sample T is 10%. Yes or no? You think we've taken 14 bags of Nabisco chocolate chip cookies. Do you think that's less than 10% of all the bags of chocolate chip cookies that exist in the world? Do you think our 14 bags of Nabisco chocolate chip cookies, if you think of all the chocolate chip cookie bags that exist from, oh yeah, this is way, way less than 10%. And I think the chat paused for a moment, so don't worry, I was repeating myself. What's the last condition right here? What is the last condition to check to see if we can make the confidence interval to estimate the mean on average? Like we're trying to figure out the estimate of on average how many chips are in a bag of chocolate chip cookies. What's the last condition? Remember, you pause right here before getting to the third condition. What is the last condition? What is the last condition? That would be, we pause, so pause isn't the condition. We pause and we ask, are we dealing with quantitative or categorical? So if it's categorical, we pause, and if it's categorical, it's success failure. But how many chips are in a bag is quantitative because we're doing the mean. T-test is means. So the condition is what? It's not success failure. Success failure is only for categorical data. If we were doing categorical, like, do the cookies taste good or something, that'd be categorical success failure, where we have to have at least 10 successes, at least 10 failures. So the third condition will be what? Don't worry if you don't know it, take a guess. Or say, I don't know. You're allowed to say, I don't know, too. We'll throw you points for all these answers. You're allowed to say, I don't know. It's the practice. Like, I don't know. That's a fine answer. Good job, Brain, right there. We'll throw you points for the I don't know. The answer is nearly normal. So nearly normal when it's quantitative, the answer is nearly normal, which deals with we have a large enough sample size such that the distribution of the mean is nearly normal, or the shape of the histogram looks normal enough, or it follows a QQ plot that's normal quantile plot, or it passes the p-value on the goodness of fit test. We cover that multiple times. It's like 4 points of the test. So sometimes I'll go into like 30 minutes on it and people will be like, I'm still confused. And I'll be like, no, 30 minutes well spent on checking normality of a distribution. So independence, we can check via random. Since they are random, we can assume it's normal. Oops, They only checked randomness. Find the shape of it right here. So let's go back to our jump worksheet. In jump, we're going to go to analyze distribution. Make sure you have the data pasted into jump. Random, 10% nearly normal. Great job, Braden, right there. Make sure to go to analyze distribution. Double click chips or column 1 if you called it column 1 and click OK. You notice it doesn't perfectly look like these. We're going to do a few steps and we're going to click stack. And then notice this goes from 900 to 1600 in units of 100. So double click here. And then do 900. Really? 900 through 1600 by units of 100. Click OK. And there's the shape of it. Does it look exactly like... Oh, it's because the bin widths. Let me go here again, and minor ticks 0. So it should look like this, and yours is probably going to look the same. 900, 1600, 100, 0. And it's got a lid, it's almost very symmetric, a little pulled on the right here, a little right skew. And you can check the skew by going to customize summary stats, not required, so I'm doing a little bit quicker. And go to skewness, I think it should be a little positive by my view of it. A little positive, tiny bit of right skew. Tiny bit of right skew. Okay. And it was this one right here. No, it's this one, right? Let me double check. Yeah, it's that one. Yeah, that one has, there we go. It's this one. Yeah, you can see right there. It's not that one. It's that one next to it. There you go. Okay. Evaluate the histogram right here. This one catches me sometimes. The histogram is unimodal and symmetric with no outliers, so one can assume the data comes from a population that follows a normal. I'm pretty sure we're picking this one. The modeling of it is done with a t-interval, but the population is probably normally distributed, which they're basically checking the nearly normal condition. So we'd say it follows a normal, but we're going to make a t-interval. To make the 95, this is literally this condition. Once again, the questions matter what you learn from them. They're checking the nearly normal condition, and they're saying the histogram looks basically normal, so it's nearly normal. That right there, that question, the whole point of it is condition 1, randomness. They didn't check 10% because it's obviously less than 10% of all chocolate chip bags that exist in the world. And then condition 3 was nearly normal, and they're saying, well, this looks pretty normal, so the distribution of the original data that we collected it from, that would be all chocolate chip bags, is probably normal. So that's the nearly normal condition you just checked right there. Like, what are we doing? Checking the nearly normal. I wish it said that, like, check the nearly normal condition. That's what that question just did. 95% confidence interval is easy, and you've already done it. There's your 95% confidence interval right here. If it gave you a different confidence, you could go over here to confidence interval under the red arrow and pick other, or one of the ones here. But 95% confidence interval is 1177.6. All the way up to, and we're just looking at the numbers for over here for 95% confident for the mean, 1287.4. You can see the margin of error is about 110, 55, half the length of the interval. So you could take the distance those are away, and then you could also find the mean of the interval by going between these numbers. What does the confidence interval say about the Nabisco's claim? Now, this is what's interesting. On average, so I would say IM, and this is what you got to know. Let's write a confidence in right here. So Braden or Noel, or I think it was, who else is here? We had one more person. Lainey. You have to know how to interpret your intervals for the test. I am 95% confident that the true mean chocolate chips in a bag of Nabisco chocolate chip cookies is contained in the interval 1177.6 to 1287.4. I am 95% confident that the true mean chocolate chips in a bag for Nabisco chocolate chip cookies is contained in the interval 1177.6 to 1287.4. So because the interval is completely above 1000, on average, there's probably more chocolate chips, but some individual bags could have less because this is on average. It's not about an individual bag, it's about on average. So because it's completely above, the mean number of chocolate chips is higher. However, the normal model predicts that a small amount of individual bags will be lower. So it's very possible an individual bag could be lower. I think we got it all correct. Woo! That's a really good question right there, Noel. And you have to know how to write your interpretation at the end. I am 95% confident that the true mean number of chocolate chips in a bag for Nabisco chocolate chip cookies is contained in the interval. See, it's kind of hard. You got to be like, I am blank percent confident the true blank is contained in the interval blank to blank. Is there another one, Noel? That was a really good one. This one should not exist over here. Well, it's not that bad. I am 95% confident that the true mean of chocolate chips contained, the true mean chocolate chips would be contained in the interval. Yep, for a bag. True mean chocolate chips for a bag. I am 95% in great. Yeah, and those are numbers, right? I am 95% confident the true mean chocolate chips per bag is contained in the interval. And then say it. Great job, Noel. Let's tell you 5,000. And make sure to be careful. It's not always mean. It's not always proportion. You have to pick based on which ones you're doing. So a lot of these, like this one might be tough right here. We'll do this one. This one can trip people up a lot. Wasn't that long of a question. I feel like time literally just escapes me. Been a busy day already. Had a meeting and I was like, what? Good meeting though. Came up with some cool ideas. Will your flight get to your destination on time? A government bureau reported the percent of flights that were delayed from 1994 to 2016. The company histogram and summer statistics show the information. We consider these data to be representative of all months. There is no evidence of a time trend. Okay. So they're saying they're independent. It's mostly, it's unimodal, somewhat symmetric. Maybe right skew, that buildup there. If you just cut that, it'd be normal. It's mostly normal, and sample size is 270, so via large enough n, it'll be nearly normal. This is 270 months. Might have an issue with sampling more than 10%. It's also, is it random? There's randomness. I think this gets me. It did say there's no trend, so I think they're trying to imply it's independent. The data do not come from a distribution that is near... No, that's fine. They're pretty normal, it looks like. The sample is neither a random sample nor from a suitable randomized experiment. That is where... See, I hate it when they have you do work and you shouldn't be doing it. It's... That's my issue. It might not be a random sample. If there's one that's got problems with, it's going to be this one. Oh, and we can select... Why can you select all of them? The interval's the easy part. And the interval shouldn't be interpreted if it's wrong. So I'm going to go with the idea that it's right. So here's the summary stats over here. And this question really boils down to taking these numbers and plugging them in the formula. It wanted 99% confidence. So the formula is y bar plus or minus t star n minus 1 degrees of freedom s over square root of n. You have to go to the t applet, which we were covering earlier today. And what are the degrees of freedom here? Does anyone know the degrees of freedom for 1,000 points? What are the degrees of freedom? Which I can tell you the t for this is going to be like t equal to about 2.6. So what are the degrees of freedom here? You have to see the question again to do that. What are the degrees of freedom? So what are the DF? What are the degrees of freedom? Degrees of freedom are found for a one sample t using the formula n minus 1. Tells you the shape of the t distribution. So the degrees of freedom are n minus 1, which is 270 minus 1. There we go. We go over to the t applet. And we say to it, go between for a confidence interval, 269, and then go to 99% confidence, and it's basically 2.6, very close to, almost rounds to it, 2.594. There we go, 2.594. And with this, we can solve pretty much all of it. So y bar is 19.733. Plus or minus 2.594 and 4.210 square root 270. And now we solve. Let's solve the margin of error. And 270 square root. There we go. There we go. And 0.6646. We do the plus or minus on the interval. And 19.3 plus this. That's 20.4. I hope. Hope it doesn't do more decimals than that. And the other one's going to be 19.07, I think. Nice job, Caden. Good to see you there, Caden. Let's try some points. That should be all right. 1907, 2004. So 1907, 2004. We'll see if that does it. I am 99% confident that the true mean monthly percent of flights that arrive on time will be contained in this interval. So this one right here, I am 99% confident that the interval contains the true mean monthly percentage of flights that arrive on time. It seems correct. I'm worried about the condition one. I'm worried about that. Yep. There we go. I said it. Frankly, if you got that wrong, I'd give you the points back. I think they're going for that. I hate it when they have you make the intervals and then they are like, it's not really random. Didn't randomize it. It's not random. I agree with them. It's not random, but why are you having me compute the interval? Tell me you can make an interval that is not properly created. Also, I don't like when they have you select multiple. They should have you check like the best. That's why I kind of want to create our own things. We might start doing that. We should have you check, is it random? And then why is it? And the best thing to do would be write a written response. And then the person could say, well, I don't really see where they randomized it, so I have questions about that. And that's how we would talk in, like, if you were to actually do a problem like this, you'd be like, well, did you really randomize it? I don't really see it being randomized here. Is it less than 10% of all flights? Well, if it's a census, it wouldn't pass less than 10%. So it's got that sort of problem too, that they probably have, this is all the information. So it's not being properly created on that too, less than 10%. And then the nearly normal looks to be good. Actually, it's 270 flights, so that's less than 10%. Or it's 270 observations, because months. It's an iffy interval. It's an iffy question. We got it right. We did it. Oh, because I didn't answer that. Is this the same one? 95% confidence? 95% confident. What are your chances your flight will leave on time? Is this the same one? We just did. Is this? Oh, what chances your flight will get? Oh, this is the leave on time. It's literally, it's gonna be the same one right here. This is gonna be probably the same as that question. So here we'll mark it in the notes. So what do we need to do, Noel, to solve this? What do we need to do to solve this? You know it, you love it, we do it all the time. What are we gonna do to solve this question? Oh, no worries, no worries. Good question. Notation, brother. Notation. Brother. Thank you, Noel, for asking these questions. What are the chances? Okay, so they're going to do the same sort of game here where they say it's not really a randomized experiment. We also know the interpretation at the end of this, that I am 95% confident the true mean of flights that will leave on time, the true mean percent. I hate that they do true monthly mean percent, but they're collecting data on percent of flights that will leave on time. And the true mean monthly percent of flights that leave on time will be contained in the interval. So I am 95% confident that the interval contains the true mean monthly percent of flights that leave on time. Like, I am 95% confident the true mean monthly percent of times the flights depart on time is contained in the interval blank to blank. Does that make sense? I am 95% confident that the true mean monthly percent of on-time flight departures is contained in the interval blank to blank. And if you're wondering why I keep saying that, that is literally our confidence interval interpretation. Don't look at what they write. Try saying it yourself. If you have the numbers, you could say the full interpretation. I am 95% confident that the interval contains the true... I am 95% confident that the true mean monthly percent of on-time flight departures is contained in the interval blank to blank. So let's just find the interval here. Okay, so what do we need to find that's not listed here? It says 95% confident. What am I missing, Noel, to solve this interval? To solve this interval, what am I missing? It said 95% confident. So what am I missing to solve for this interval? You can see a lot of what they gave us here. Well, and so you're right in this instance, because Mr. T is mean, if you're doing drugs, since it's means, you see means, that means T. So we previously were using Z for P hat plus or minus Z star, and P hat Q hat over N square root. So that's what we were previously using. And so with this right here, we're using T. So what is the T? It said 95% confident. So what's the T? I have a guess of it. So every T has with it what? Every T has with it what? These are the learning objectives. You have to know every T has with it what? What's that stand for? Every T always has a, I think you found it, Noel. Great job. So Noel found it because I think Noel found the degrees of freedom. The degrees of freedom for this T is 269 from n minus 1 to 70 minus 1 is equal to that. That's degrees of freedom. You now go over to the T applet. Noel, that does sound correct, basically close to the classic 1.96 because lots of degrees of freedom, T close to Z. And what do the degrees of freedom tell you? The degrees of freedom tell you the shape of the T. So now we have 269 degrees of freedom telling us the shape of this T, and we put in 95% confidence, and Noel has done it to 4 decimals, 1.9688. So we go over here and we write in 1.9688. We put in the standard deviation of 5.013, and then we square root by 270, plus or minus over here, 77.904. There we go. That's got it. So 270, 5.013 divided by that, times 1.9688. So that's basically 0.6. Man, that's nice. Something other is 0.6, right? With it being 0.6, that's easy. Because it was 77.9 plus 0.6 is that. 77.9 minus 0.6 is this. So it rounded so nice and neat. We got it right. Once again, the last bit of this is to solve, add, and subtract. 77.9 plus or minus 0.6. And that is equal to 77.3 when you subtract, and 78.5 when you add. And there's the interval from the lower to the upper. Does that make sense right there? I am 95% confident that the true mean monthly percentage of on-time flights is contained in the interval 77.3 to 78.5. Do you have another one, Noel? Yay! So finding the T is usually what gets people stuck. Usually people say, how do I find the T? And I'm like, got to use the T applet. You got to know. We got right here 90. Oof, Noel, I'm not going to get this one. I'm going to get this one very easily. I got that one right. 99 degrees, 13 degrees of freedom with 99% confidence. That's a tough one. Yep, that one I'm not going to get. And then you go back here and you say, well, let's just find the answer. 13 degrees of freedom, 99% confidence, 3.01. It's harder to get the ones where the degrees of freedom is smaller for me. There we go. And so you can see you can guess them a lot of times if you know how the degrees of freedom work. Is there another one to do? I know a lot of the T distribution because I've done it a billion times. 1,000,001 times today. So it helps. Practice. See here if we got any other ones. We'll do this one. Nice and quick one, it looks like. A quick problem. 31, 4 to 3, stat tool 1. I'll do it next. You got Noel. So a nutrition lab took 40 hot dogs to see if their mean sodium content was less than this. And they found that the interval contained the value. So they'd say, I am 90% confident the true mean sodium content of these hot dogs is contained in the interval 317 to 327, which means they were somewhere between for the estimate, like 322 plus or minus 5. What would you tell the lab about whether the hot dogs meet the regulation? They want it to be less than this. So it's possible the hot dogs are higher than this. So I would say they do not meet the regulation of being less than that because the interval goes above it. It contains it and it's above it. So they do not, the interval contains the value. Therefore, the lab should conclude the hot dogs do not meet the regulation, do not satisfy the regulation. Pretty good. That's a good question to understand what's going on, because I'm saying the true mean sodium content is somewhere between 317 to 327. I'm rounding it. And because of that, we'd have evidence to believe that, you know, it could be higher than what they're allowed to be. So that's not good. That is not good. Meteorological. Yeah, does that make sense? Because they could be above it. Imagine you said, I'm going to score anywhere from, you need to at least an 80 to pass the class. And you say, I'm going to score anywhere between a 50 to a 60 on the test. And you say, well, you're not going to pass the class. And they say, well, I'm going to score somewhere between a 70 to a 90. Well, you could pass the class then. So they might be above the regulation because the high of the interval goes above what we saw as possible. So based on meteorological, here we go. Oh, this is a whole interpretation one. This is a very good one too. This is all about interpreting your intervals, knowing how to read them properly. Okay, so what I would like you to do is write the interpretation of the interval to begin with. So if you're watching this at home right now, look at the interval. 35 inches is the estimate. 4 is going to be the margin of error. With 95% confident, for the true mean snowfall this region gets. So try writing it in the chat. I'll give a moment here, but then we'll use that and see if it accurately represents what this question says. So think about it, what I said, and think about how to fill in the blanks. Try writing it out, write it in paper, say it out loud. The more you write it, the more you say it, the more you think it, the more you can do it on the test. So when we give a confidence interval, we always give the percent confidence listed in the question. We always give a lower and upper bound, which is going to be the high estimate and the low estimate. There's the center of the interval, which is 35 right here, which is what we saw over this time frame. Then there's a margin of error plus or minus. So you have to go plus the margin of error minus the margin of error to create the lower and upper, which is the last part of the interpretation, is containing the interval blank to blank. And then we talk about what we're trying to estimate. In this instance, the true mean snowfall in this region. The true mean snowfall in this region. Any idea how we'd interpret this? Give it a try. Give it a try. What would it say? What would we write? Noel, Braden, Laney, how would we interpret it? I am 95% confident that the true mean snowfall of this region is contained in the interval. True. And then basically, Braden and Noel, if you put your answers together, perfect answer. So let's write some points. I am 95% confident that the true mean snowfall of this region is contained in the interval blank to blank, 31 to 29. Great job. Tag team right there. Let's show you some extra points. So they say right here, during the past 95 winters, the region got 31. You notice how we said none of that? That's wrong. We know how much they got during the past few winters. They got 35 inches on average. The interval is about the population mean, not the snowfall of individual winters. So we're trying to estimate the truth for that region for all time. It's not about the sample, because we know what happened during the last 900 winters. Oh, nope. There's a 95% chance the region will get between this and this snowfall this winter. No, we're trying to estimate the truth for like all winters, not like this upcoming winter. That'd be an individual point, not a mean. So this statement is incorrect because the confidence interval only estimates, no, it doesn't estimate what happens in the interval. The confidence interval estimates, the interval is for the population, not for predicting individual winters. I am 95% confident the true mean, which is the population mean, is contained in the interval. There would be 31 to 39 inches of snowfall on the ground 90% of winter days. No, it's not about winter days. It's about the true mean snowfall over the course of a winter in that region on average for that region. So it's not about days, it's about on average for the region. The confidence interval was based on sample snowfall. I'll show you. No, this might be it actually. The confidence interval was based on sample snowfalls amounts for several years. The confidence interval only estimates what happens in the year. No, that doesn't. The interval is for predicting the average snowfall, not for next winter. I believe this is it. Residents can be 95% sure that the area's snowfall is between this and this. Now, this one's close. I am 95%. Wait. No, the past century is not the answer. This one might be true. I'm confused about how to understand what to interpret. Confident that the true. That's the context then. After the true, you have to see, are they talking about the mean, the proportion, and what's the context? I am 95% confident that the area's true average snowfall this looks correct, but I'm worried they... Okay, I think this one is the correct one. Let me double check. The interval is for the population mean, not for individual winters. The area's average snowfall is between this and this. That's not talking about one winter, it's talking about on average. The confidence interval only estimates what happens in the years. That is completely false. Confidence intervals are not for the sample, they estimate the truth. The interval is for the sample mean snowfall, not for predicting the snowfall of individual winters. It's just, this is not the best, but it's not bad. It's the best of what we got. Residents can be 95% confident that the average snowfall during the past century. No, we know the average snowfall during the past century was 35. That's the center of the interval, which created the estimate. We should be good. Yeah. Got a little worried. Just the interpretation they gave for the correct one was a little like, I'd like it to be more exact. There was nothing really wrong with it. I am 95% confident that the true mean area's average snowfall is contained in the interval 31 to 39. They can say residents, people are, one can be. So I like to say I am. It's good. They make you think like, what are you actually saying? But notice how this is the close to I am 95% confident that the true mean area average snowfall is contained in the interval 31 to 39. And we wouldn't say we're confident about what happened during the last century because we know during the last century it was 35 on average because that's the sample mean. So, and there's a cow one too that does this. Is this making some sense, Noel? This one is all about interpretations, and it's very repetitive and knowing why things are right or why they're wrong. And they have to think, what are you estimating with the interval, the true mean? So we don't estimate the sample. We know what the sample is. There's no estimation of the sample because the sample is an estimate of the truth. Does that make sense? Like you would never say, when we did the Nabisco problem, you wouldn't say, I am 95% confident that the bags have this on average. We know what the average for the bags were. When we took our 14 bags of chocolate chips, we saw on average 12,032. But I'm 95% confident that the true mean for all bags, and it's true mean because it's quantitative, because it's true mean because when we measure snowfall, it's how much snow fell on the ground. But if you look at something like the proportion of legendary Pokemon, that would be, I am 95% confident the true proportion of legendary Pokemon is contained in the interval blank to blank. So Pokemon in being legendary is proportions because that's categorical. So the interpretation for this one would be, I am 95% confident the true proportion of legendary Pokemon is contained in the interval 6.4% to 10.2%. That's a lot of possible... Nearly 8% of Pokemon are legendary. It's a lot. It means out of the first 151, there should have been like 12 or 13. I think they just started to go crazy on the legendary Pokemon in later gens. So I am 95% confident. This also violates the 10% condition because we've taken more than 10%. So what we could do is go here, go to tables, subset, random sample size of 80. And now we have a random sample of Pokemon. And we could estimate the true proportion of legendary Pokemon without breaking the 10% condition. And confidence roll 95. I am 95% confident the true proportion of legendary Pokemon is contained in the interval 5.15% to 18.5%. And the reason it's true proportion is because it's categorical. So is a Pokemon legendary is a categorical question. How much snow fell on the ground is a quantitative question. When we do quantitative questions, I am 95% confident the true mean, give the context. And so we'll practice this a lot in class. I'm going to check something to see if it's ready to go. So Noel, you get to see a sneak peek of class right here. I should have put my courtroom on I'm supposed to have it on my quick key. Maybe I'll do that right here too. Yeah, keep asking those questions. Keep asking. Let me see if my courtroom is working. I should have put it on my quick key. Ubot's there. Oh my gosh. So it is working. We got Mr. T in the courtroom. We got Mubot. I don't think he can really talk inside of here, though. Hello? Mubot? Yeah. We got a courtroom for today, so it is working. And let me put it on the my hotkeys over here because I don't have it on a hotkey. Should like remove an effect I'm no longer using. I think the rainbow. I don't know. It's like I remove an effect and I'm like, oh, I missed that effect now. Oh, the temperature and the chaotic no longer work. Okay. So these have to go away because they don't work. And then we need to go here. What did they do? Newbot's putting me on trial and he won't get to talk today. But, and then do I have the screen capture here? Getting everything ready. Maybe I could do a screen capture again. Or I should be able to bring over a screen capture. Here, let me put this over here. And, where is it? OBS. There's so many things you have to set up. Scene. Scene, yeah, it's scene. Okay, scene. And then, where's courtroom? Courtroom, found it. Okay, let's see if I can switch between it. Mutebot! Okay, let's go over here. Good to go. Let's go to the main screen. Going into witness protection, I like it. And I need to go to main screen capture. Where's main screen capture? Main screen capture. It should be, oh no, it's behind me. So it's got to be camera green screen. There's me. X-Pen, it's X-Pen. Okay. Woo! We don't want to block Mr. T. Crop this. Will that mess up things? You're seeing the behind the scenes work I do. There we go. That shouldn't mess up the other thing. Null hypothesis. Innocent. They spell innocent. I can make it bigger when I write in class. Okay, I think we're good to go. Ubot going to witness protection. Well, we're going to have fun in class. Till then, bye for now, everyone. Bye.